indexing is very, very important. So it doesn't really matter whether we have a database hosted on our private network or we have a database hosted somewhere in the cloud. As long as we have a database, we have the data stored in a database, and we need to maintain the data, we need to query the data, then indexing is always very important. And the concepts, the techniques that we will be covering here should be common to any type of indexing implementation. So there are many different types of index implementation. Each vendor may have different implementation details, right? So there are many types of index implementation, but the concepts, the techniques we are covering here should be all common to any type of the index implementation. So when we use indexing, so we have indexes in our database, or in other words, we index our columns of a table, or we create indexes on our database data, then there is a common problem, fragmentation. So index fragmentation, that's unavoidable. It's just like laundry, right? No, we need to do the laundry every so often. So it's just a chore, it's unavoidable. And whenever we change data, like, we modify, update our database content, especially in an online transaction processing system, then we will have this fragmentation, index fragmentation problem. If we have a reporting problem, like, your query performance is slow, that means most likely you got some issues with indexing. So that's index fragmentation, most likely is one of your root causes, right? So in a transactional environment, we change the database content a lot. We process an order, the order needs to be saved in the database, so the database content is constantly changed. So in an OLTP environment, we may have more frequent index fragmentation problem. In a reporting environment, mostly we just do reporting. Very rarely we change the data. Then index fragmentation may be less a problem. But that's just a very general statement. You think about today, right? In a reporting environment, we need to constantly refresh the data. So when we do a ETL, when we refresh the reporting data, usually there are two common approaches. Number one, you will do ETL occasionally, for example, every night. Then when you do that, you will drop all indexes, load new data, and then create new indexes. If that's your approach, then probably index fragmentation is less a problem, because during the business hours, there may be some changes, but in a reporting environment, the changes are not that significant. On the other hand, if you have near time or near real time data refresh, then you need to be more conscientious, more mindful of index fragmentation, because the data is constantly being updated, right? So it's just similar to a transactional environment. So just keep this in mind. If we have this index fragmentation problem, then our I/O, disk I/O, will be slower. So usually our data is stored in storage on hard drive. So when we need to use the data, we need to go get the data, right? That's what we meant by I/O. If your index is fragmented, meaning the database engine needs to go to more places to get the indexing data it needs to process your query. So more places to get the required data, meaning more trips to the storage. More trips to the storage mean more time, right? If it needs more time, then the performance will not be great. So that's the reason why we care about index fragmentation. We want to make sure we get the optimal I/O. Okay, we want the I/O input output, or getting the data from the storage, or saving the data to the storage as efficient, as quick as possible. So we want to make sure we address this index fragmentation problem. If the problem is relatively serious, the bottom line is that we care about the performance, right? Especially the performance when we create a report. So we learned when the database content is being modified, then we may cause index fragmentation. To be more specific, if we use insert, update, or delete these commands a lot in our environment, then we may have more an index fragmentation problem. And if we want to look under the surface, right? So when we do insert, update, then the new data may cause a page to be split. A single page may be broken up into 2 pages. So that will cause index fragmentation, because your data will not be at just one location. Your data may be stored at multiple locations when that happens. You are wondering about what the page is. Okay, the page is just a unit of storage, and you will see extent as well. So on a page, we have extents. Those are all units of storage, and the different operating systems have different sizes for a page and different sizes for an extent. When we run the delete command, then we will create some hosts in our pages and our extent. That will cause index fragmentation as well. Okay, if we have a large record which cannot fit in one page, then we may create some fragmentation as well. So those are root causes under the surface. But generally speaking, if we run insert, update, delete a lot, then we may have more an index fragmentation problem. And we have several types of index fragmentation. And I can share with you the type of fragmentation we are most concerned with is the logical fragmentation. So the middle one, logical fragmentation means the order of your index values. For example, if you index on the customer ID, the order of the index values is the numerical order of your customer IDs, right? So with the logical fragmentation, your order of the index value, or your logical order, is different than the physical order of your index data, because your index data will be stored in storage. So there is the physical order of pages and the extents, right? So this is the type of fragmentation we are most concerned with, meaning the logical order of your indexes is different than the physical order of your indexes. Okay, logical order is based on the indexing value. Physical order is based on the storage. There are other types of fragmentation, internal and extent. You can read them, but again, our focus is on logical fragmentation. And how do we detect index fragmentation? How do we investigate index fragmentation? How do we know whether we have this problem, right? And there are tools and there are code that you can run, resources you can use. And this is the place where implementation makes a difference, because the code, the tools that you run on a SQL server will be different than the tools and the code you run on an Oracle server, so to speak. But I think the concept or the ideas, or if you just use the regular standard SQL code, then they should be similar. Okay, a lot of the tools can support multiple different platforms, then they will operate in a similar manner. With the SQL code, you may just need to change some system catalog names. Okay, like system view, different system views, or different system functions, different whatever, right? So those are implementation specific, but the concepts and the techniques are the same. So we can use on SQL Server, we can use the dynamic management view. So this view can allow us to detect whether we have the fragmentation problem. And then there are different options when we use this code, right? You can read the details. Again, we want to pay attention to the logical fragmentation. So the logical fragmentation is what we are concerned with. If we have an index fragmentation, how do we deal with it? How do we fix it? Right? So generally speaking, you can rebuild the indexes, or you can just reorganize the index. So if the problem is very serious, then you will need to drop the index and then rebuild or recreate it. If the problem is a minor problem, you can just reorganize the index, minor repairs, so to speak. And when we fix the index fragmentation problem, usually we can fix the problem and we can make the data available for use at the same time, meaning your users can still access the data, can still access the indexes when they run the queries. At the same time, you are fixing the fragmentation problem. So especially when we just doing some reorganization of the indexes, right? So the problems are not that serious. We're just reorganizing the indexes. In those scenarios, we can have the data available to our users when we are fixing the problem. So that's one category. Another category is when we fix an indexing problem, especially when the problems are serious, then we will just take the tables or whatever, the database offline, and then we will fix that problem. At the same time, the data is not available to our users. Okay, so you will just focus on fixing the index fragmentation problem and will not make the data available to your users until you are done. If we do that offline, so to speak, then the problem can be fixed probably sooner. Okay, so in other words, if you fix the problem at the same time, you make the data available to your users, then it may take 5 hours to fix the problem. But if you take the database offline to fix the problem, it may just take 1 hour. So it really depends on your business requirements. And this is very important. Pay very close attention to the general guidelines. Okay. When we have an index fragmentation problem, even the problem is very serious, it depends on our environment. It depends on the size of our index file, right? If we just have a very small index file, the file may have very, very serious fragmentation problems, but the file index file is so small, we don't have much data, and then the entire index file can fit in memory at one time, at once. Then, though the problems may be very serious, we don't need to worry about that because, they can all fit in the memory. When the data is in the memory, performance is very good. Okay, we are concerned with index fragmentation because we are concerned about the time it's going to take to get the data from the storage into the memory for processing. So a small index file, small data, or small table, that's fine. Don't worry about the index fragmentation problem. But if we have larger tables, larger index files, more data, then pay very close attention to the guidelines here. If the logical fragmentation is 5% or below 5%, we are going to run code to check that, okay? Then you don't need to worry about that because it's just a very minor problem. If the problem is between 5% and 30%, then, well, it's getting more serious. You need to do something, but you can probably just make some fixes, right? Some minor repairs, then you will do reorganize. If the problem is very serious, the fragmentation is above 30%, then by all means, you have to drop the index and then recreate it. It's just like, a house, right? If you have some minor issues in a house, you can do some renovation, remodeling. If the condition of the house is so bad, problems everywhere, then you will need to tear down the house and then rebuild the house. Now, we are going to do some code review. And this is very interesting. And this code is production ready, okay? You can take this code and then use it at work if you are working with indexing now in the industry. So we will use dynamic SQL and the cursor. So now you can tell why dynamic SQL and the cursor are so important, right? Because they are commonly used in the industry for many, many common data tasks. So we are going to declare some variables here and going to get data from system views. Okay, so we have one dynamic view here, and then we will join that to another system view indexes. Join on the common columns, and then we are looking for indexes with the logical fragmentation greater than 30. Remember this threshold, right? And this is the logical fragmentation greater than 30. So what we are doing here is just to create a report, and we are declaring a cursor. In this cursor, we will identify indexes with the fragmentation greater than 30. And then we will open the cursor, doing some procedural processing. Here, we are just creating a report. We're not doing any repair work. Okay, so we're just creating the report one index at a time. And then once we are done, we close the cursor, clean up the memory. So let's run the code. Okay, you can see this report. It's pretty detailed, right? You see this table got an index, which is 66% logically fragmented. And then this one also pretty fragmented. So you go down the list. This is a very detailed report. And this report lists indexes which have a logical fragmentation greater than 30. So they all need to be worked on. Okay. So we created the report. Next, we will use dynamic SQL and the cursor to fix the problems. So when we fix these indexing problems, we are doing the repair work in a database. In a database, we may have a lot of indexes, right? Depending on the size of your database, we may have several hundred indexes, which need to be repaired. In a small database, we may just have a few, right? So that's the reason why we want to use the dynamic SQL. You don't want to just write a specific SQL statement to fix one index. You want to write a template or a formula which can run a query in a database at the runtime to identify all indexes which need to be repaired. So you have just one formula, one template, and then at the runtime, you run the query to identify the indexes which need to be repaired. You plug in these index files into the formula or the template, and then you can fix the index one by one, right? Because when you repair an index, you rebuild or you reorganize, you cannot do set-based operation. You can only do procedural processing, one repair, one rebuild at a time. So that's the reason why we want to use the combination of dynamic SQL and cursor. Again, so common. This is so common in the industry. This combination is being used everywhere. Okay, so let's look at the code on how we can fix the problems. Okay, so we will declare some variables, and then we will define a cursor. In the cursor, we will identify the problematic indexes at the runtime. Again, we are looking for indexes with a logical fragmentation greater than 30%. 30%, keep this in mind. Okay, keep the guideline in mind. And then when we repair the problematic indexes, we can only repair one index at a time. So we have to use the cursor. We have to do the procedural processing. And then we use the dynamic SQL, the template or the formula to create a specific regular SQL statement to fix that specific index, okay, the specific problem. So we are using this while loop to fix the indexes one at a time. In each iteration, we will fix one problem. So once we are done, we will close the cursor and then clean up the memory. So I'm not going to rebuild the indexes on my computer because it's going to take a while. Instead, we want to print the regular SQL statements generated by the dynamic SQL. So let's see how we do that. So we don't want to execute the command. And we don't care about this. We don't want the message to be printed. So comment this out. So no message, don't execute. Instead, we will print the command. Okay, so bear with me just a second. We want to print this. What did I do? Control Z. So I want to print this. Copy it. Put it here. Paste. Okay, this looks good. So let's read the code one more time. Don't print message. Create the regular SQL statement using dynamic SQL. Do not execute, print the statement. And then go to the next one. I think we are fine. Okay, so let's run the code. So we are not fixing the problematic indexes. We're just printing the regular SQL statements, which will be generated by the dynamic SQL. So run it. And you can see, right? So many regular SQL statements were generated, one for each problematic index. You see outer index and then the index name, right? So how many? A lot. And again, this is a very typical example of using dynamic SQL and cursor to create regular SQL statements. We don't need to write a specific SQL statement for each specific problem. We just use dynamic SQL and cursor, and then at the runtime, we will run a query to identify the problems that we need to fix, right? And then the dynamic SQL and the cursor will create a specific SQL statement to fix each specific problem. Very, very cool technology, commonly used in the industry.